Continue from number 11. Here it says a loaded spring performs simple harmonic motion with an amplitude of 5 centimeters. So see the maximum acceleration of the load is 20 centimeters per second squared. Calculate the angular frequency of the motion. What it means is that in this question, you have the acceleration. Just relate this to the formula you have in circular motion. The acceleration is 20 centimeters per second. To change centimeter to meter, are you listening? You divide by 100. So 20 divided by 100, we change it from 20 centimeters per second squared to 0.2 meter per second squared.
Yes, sir.
Exactly.
Yes, sir.
It says that the maximum displacement is what? 5 centimeters. Take the maximum displacement as the radius of take the maximum displacement as the radius of the motion. So 5 centimeters divided by 100 will give you 0.05 meter. The question says you should calculate the angular frequency of the motion. In this case, angular frequency is the same thing as what? As W. Angular frequency is the same thing as W. Do you understand?
Yes, sir.
Just like angular speed. So they are, those terms are used interchangeably. Angular speed or angular frequency. So W is what? You know that your acceleration is how W squared. I showed you that before.
Yes, sir.
So that means 0.2. Acceleration is how W squared. That means what? That means 0.2 is radius times W squared. So W squared will be 0.2 divided by 0.05. This is just like dividing both sides by 0.05. What do you get? 4. If you press your calculator, 0.2 over 0.05 will give you 4.
Yes, sir.
W squared is 4. W is square root of 4. Your angular frequency or angular speed is 2 radians per second. Do you understand?
Yes, sir.
Question 12 says a simple pendulum makes 50 oscillations in 1 minute. If a pendulum makes 50 oscillations in 1 minute, frequency is number of oscillations over time taken. You understand? Frequency is number of complete oscillations made per unit time. So frequency will be 50 oscillations over what? 1 minute.
Yes, sir.
So 50 revolutions. Oscillations means the same thing as revolution. So 50 revolutions divided by what? 50 revolutions divided by, what do you get? Well, number 12. 50 revolutions divided by 60 seconds will give you 5 over 6. Do you understand?
Yes, sir.
That's your frequency. The question says we should find the period. What is its period of oscillation? Period of oscillation is 1 over frequency. Period is 1 over frequency. That's 1 divided by 5 over 6. That's 6 over 5 or 1.2 seconds. Do you understand?
Yes, sir.
Huh?
Yes, sir.
Number 13. A boy timed 20 oscillations of a certain pendulum 3 times and obtained this 44.3
seconds.
44.3 seconds, 45.5 seconds, and 45.7 seconds. Calculate the mean period of oscillation. First thing you need to know is that the total time for 20 oscillations was measured as 44.3, 45.5, and 45.7. So the average total time is what you should get first. Average total time for 20 oscillations will be addition of the 3 values the boy got divided by 3. That gives you 45.2.
Yes, sir.
Period is time taken for 1 complete oscillation or 1 cycle, 1 complete cycle. So it will be total time for 20 cycles divided by 20. Do you understand?
Yes, sir.
That's 45.2 divided by 20 to give you 2.26 seconds. So average period of 1 oscillation or 1 revolution is 2.26 seconds. Exactly.
Yes, sir. 45.2 seconds.
Number 14, I mean.
Yes, sir.
A student found out from a simple pendulum experiment that 20 oscillations were completed in 38 seconds. What's the period of oscillation? Period is time taken for 1 oscillation. Abi?
Yes.
20 oscillations were completed in 38 seconds. So period, time for 1 oscillation will be total time over number of oscillations.
Yes, sir.
38 over 20, 1.9 seconds. Exactly.
Yes, sir.
Number 15, 2 simple pendula, X and Y make 400 and 500 oscillations respectively in equal time. If the period of oscillation of x is 1.5 seconds, what's the period of oscillation of y? We use the formula. Look at the formula here.
Yes.
T1 times N1 is equal to T2 times N2. Because the pendulum are what? Two simple pendulums. They are of the same length. The pendulums or the pendula have what? They have what? Equal periods. Do you understand?
Yes, sir.
So, question says, so let's use a shorter method here. And I'll read the question again. The question says, two simple pendula X and Y make what? 400 and 500 oscillations. So, number of oscillations made by X. Number of oscillations made by X. Let me increase that. Number of oscillations made by X, 400. Number of oscillations made by Y, 500. Made 400 and 500 oscillations. Okay, I've written it already in capital letter. The question says, if the period of oscillation of X is 1.5 seconds, period of oscillation of X, 1.5 seconds, and the period of oscillation, what is the period of oscillation of Y? Period of oscillation of Y is unknown. So we use the formula T1 N1 is equal to what? The hint is here already.
T2 N2.
T2 N2. You understand?
Yes, sir.
So that means we are going to use TX NX. Are you getting it?
Yes, sir.
Period of oscillation of X times number of oscillations made by X is equal to period of oscillation of Y times number of oscillations made by Y. So TX NX is TY NY. What does that give us? That will give us period of oscillation of X, 1.5. Number of oscillations of X made by X, 400. Period of oscillation of Y, we don't know. Number of oscillations made by Y, 500. So that means 500 TY. We are looking for the period of oscillation of Y. 500 TY is 1.5 times 400. What does that give you? TY is 1.5 times 400 divided by 500. So the period of oscillation of Y, 0.8, that's 1.5 times 0.8. That should be 1.2 seconds. Exactly.
Yes, sir.
This is how I got 0.8. 0.0000. 4 over 5 is 0.8. You understand?
Yes, sir.
1.5 times 0.8 will be 1.2 seconds. Take note of that. Number 16 says, a pendulum bob executing simple harmonic motion has 2 centimeters and 12 hertz as its amplitude and frequency respectively. Calculate the period of oscillation. This is a similar question to what we just did. A, amplitude of oscillation. Take that as the maximum radius or distance from the center of the circle. Do you understand?
Yes, sir.
That gives you 2 centimeters. 2 centimeters. Centimeters is not the SI unit of length. So you have to change it to meter. Divide by 100. 2 over 100 will give you 0.02 meters. So frequency is 12 hertz. You need period. Period will be 1 over 12. You understand? That gives you the frequency. The question says, calculate the period of the motion. You don't actually have any business with R. It was just kept there to confuse. 1 over 12. What's 1 over 12?
0.083.
0.083 seconds. That's your period. In number 17, it says, the length of a simple pendulum is increased by a factor of 4. By what factor does its period increase? The length of a simple pendulum is increased by a factor of 4. By what factor does its period increase? That's a simple question. Length of a pendulum. Period of a pendulum is given by what? Period is equal to 2 pi root L over G. You know pendulum, that's swing. To measure time. The period, time taken for one complete oscillation. One complete oscillation is to go one complete oscillation is to, let's say this is the pendulum. If it goes from, if it goes from A to B to C, this is, okay, excuse me, this is one half of an oscillation. If it comes back, that's another half. That's a full cycle. Just like one half cycle, one cycle, full cycle. Do you understand? If it goes from A to C, that's half a cycle, 180 degrees. When it comes back to A, from its initial point, that's 360 degrees. So take note of that. It's then the period is calculated using the formula 2 pi root L over G. L is the length of the pendulum and G is the acceleration due to gravity. Do you understand?
Yes, sir.
2 pi, these 2 pi and G are constants. So I can write this equation. If I put all of this behind root L, I can write this equation as T is equal to, period is equal to constant times root L. Do you understand?
Yes, sir.
So that means I can say T over root L is a constant. Abby, if I divide both sides by root L will cut root L here, and root L will come to the, you understand, underneath of T. Do you understand?
Yes, sir.
So T over root L is what? Constant. That means T1 over root L1 is T2 over root what? L2. Do you understand what I'm writing?
Yes, sir.
So they are saying that what happens when the length is multiplied by 4. So L1, make it L. Initial length, make it L. Final length, L2, make it what? 4L. Do you understand?
Yes, sir.
The question says if the length of a pendulum is multiplied by 4, what happens to the period? So let the initial length be L1. Let L1, the initial length, be L. Let L2, the final length, be what? 4L. So you have initial length and final length. Let initial period be T1. Let final period be what? T2. Do you understand? So if T1 is what? Written as T, T1 over root L will be what? T2. T1 over root L1 will be T2 over root what? L2. Do you understand what I'm saying?
Yes, sir.
Now, your T1 is T over root L. T2 over root 4L. You understand? Because we said L2 is 4 times L1,
4 times L.
which is 4L. What would that give you? Root L. If you simplify root 4L we simplify it to root 4 times root L, Abby, from your sorts.
Yes, sir.
Root 4 is 2, so that will change to what? To root L. So if you look at it very well, T2 over 2 root L will be here. Root L will cut root L on both sides, and you have what? T over 1 is T2 over 2. If you cross multiply, T2 will be 2T. That means T2 is what? 2T1. Which means that the period is doubled when the length of the pendulum is multiplied by 4. Is that clear?
Yes, sir. Yes, sir.
So those are some other simple questions on circular motion.